Hi, and happy Thursday. Today, we will continue reviewing the fundamental accounting principle and talk a little bit more about permutations. Several of you guys did a really good job yesterday. We had a couple of perfect scores, quite a few perfect scores, actually. If not, that's okay. Just keep practicing, and we'll try to get better. Once again, if you have any questions, please reach out to me, either through It's Learning Messenger or email, or join the Google Meetup this afternoon at 2:30. Two of you joined yesterday, so thanks for doing that. If you have any questions, just want to say hi, go ahead and join today. And then I know the test we took right before break, I still haven't put that in. By next week, I'll have all the grades up to date. I was kind of waiting to see what was going to happen with school before I made any decisions on the grades, but now that it looks like this is the new normal, I'll go ahead and get those grades in so you guys can kind of see where you're at. So if you haven't finished the test from before break, today's the last day of the week for us. You have till Tuesday off, so it might be a good time to get that work done. Remember, the test can be open notes. From here on out, everything is going to be open notes, open resource, okay? So, fundamental counting principle. We talked about this yesterday. It's basically how many choices do you have? So imagine we go to Wendy's and I say, I'm going to buy you lunch, but there's a few conditions. You can buy one of these sandwiches, okay, the double cheeseburger, or the chicken sandwich. You can get either chili, a salad, French fries, or a baked potato. And I'm only going to let you choose from these 5 drinks. So either Dr. Pepper, Coke, Diet Coke, Coke Zero, or Sprite. Okay, so if we think about it, counting principle, we just multiply the number of total choices for each decision, and that will tell us how many total decisions, how many different ways I could order off of that menu. So our first decision, what sandwich we want to get. So for this, we have 3 choices. So we're going to do 3 times second decision. How many choices do I have for a side? So 1, 2, 3, 4. 4 choices, so 3 times 4. And our third choice, this one is what drink, so 1, 2, 3, 4, 5. So 3 times 4 times 5. We multiply that, 3 times 4 is 12, 12 times 5 gives us 60 total different choices. So that was the fundamental counting principle we talked about. It's basically how many choices do I have, and then for each of those choices, how many options are there? Okay, now here's our example. We're going to do another one just like that. It says the Indiana license plate has a combination of 3 numbers followed by 3 letters. Okay, that's the standard one. Obviously, people make their own. They pay extra and get a custom one. But the standard license plate has 3 numbers. So if we think about that, 1, 2, 3 choices for a number. And then there's 3 letters. So 1, 2, and 3 spots for that. Now, for numbers, there are 10 different choices. You might think, why isn't it 9? 1 to 9. But keep in mind, we also got to have the number 0. Okay, it could be a 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That gives us 10 choices. Okay. So now, on a license plate, they can repeat. So we could also have 10 choices for the second number and 10 choices for the third number. Now, if we think about it, how many different letters are there? Hopefully you guys know, 26 letters, A through Z. So we have 26 options for that letter, 26 for the next one, and 26 for the third. Now this is going to tell us how many possible ways we could have 3 numbers and then 3 letters. In reality, Indiana isn't going to let all of these pass. Okay, if there's profanity in it, they're not going to let it go on a license plate. If it's suggestive, they're not going to let it go. But this is how many possible ways there are. So 10 times 10 times 10 times 26 times 26 times 26. Now, I don't expect you to do that in your head. I'm going to pull up the calculator we talked about yesterday. So 10 times 10 times 10, that takes care of our 3 numbers. And then times 26 times 26 times 26. And we type that in, and we get 17,576,000. Okay, so our final answer, 17 million, what was it, 576,000. So obviously there are quite a few options for license plates, and that's just the ones that follow this format. There's some special license plates. If you sponsor something, you sponsor a college, where they're different, but this is the generic Indiana license plate. Okay, so that's the counting principle. We had talked about that yesterday. Lots of you did really good on that on the review. Okay, so now, permutation. This is when we arrange things and order is important. So it's what we talked about yesterday. Remember, permutations with repeated items. Okay, this is basically the same formula. I think yesterday maybe instead of the word different, it said distinguishable. But the number of different permutations of n objects where there are n repeated items, n2 repeated items, and k repeated items. So each repeated one we put on the bottom with a factorial. So first, n factorial goes on top. That's how many objects there are. So it says find the number of distinguishable permutations for the letters in the word Indiana. So the first thing we're going to do is count how many different letters there are. So 1, 2, 3, 4, 5, 6, 7. 7 different ones, so 7 factorial. That's going to go on top because there's 7 letters in Indiana. Now, we have to think how many of them repeat, because remember, if I write Indiana and then I flip these two A's, it's not distinguishable. It looks exactly the same. We're trying to figure out how many different ways we could order these so that it would look different. So if we look through here, there's a couple different letters that are repeated. The I is repeated 2 times. So for that, we put 2 factorial. Ooh, let me read. Get my eraser. All right. So 2 factorial. Okay, now that was for the I. The n is also repeated, so we have to multiply it by another 2 factorial. And then finally the a is repeated. There's 2 a's, so that's also 2 factorial. Now, the reason we use 2 for each of these is because there were 2 i's, 2 n's, and 2 a's. Okay, if there had been a third, if Indiana was spelled with another a on the back, if it was INDIANAA, then we'd have to have a 3 factorial here to represent the a's, but it's not. So now, let's start with 7 factorial. We type it in, remember, clear it, hit 7, put your exclamation point, hit enter, we get 5,040. That's going to go on top here. Now, we're going to have to divide that by whatever we get on the bottom. Now, keep in mind, 2 factorial, so we'll clear it, 2 factorial, that's just 2 times 1, which is 2. On the bottom here, we're going to get 2 times 2 times 2. Now be careful, 2 times 2 times 2, it's easy to say 6, but it's not. 2 times 2 is 4, 4 times 2 is 8. Okay, so then think about it, 5,040 divided by 8. So let's clear that, 5,040 divided by 8, and we get 630 different ways. 630 distinguishable ways. Now remember, that was when there were repeated items. Okay, sometimes we're going to have a permutation without repeated items. For example, here 6 runners are competing in the 100-meter dash. Assuming there are no ties, how many different ways can they finish from 1st to 6th place? Now, if you're a runner, you can get 1st, 2nd, 3rd, 4th, 5th, or 6th place. However, you can never get more than one of those. Okay, you're either 1st, 2nd, 3rd, 4th, 5th, or 6th. You're not 1st and 3rd place. Okay, that's not possible in a normal race. So, if we think about it, in 1st place, that first slot, if 6 runners are running, there are 6 different runners that can get that spot. Now, 2nd place, one of the runners has already finished, okay? So there's only 5 runners left that could possibly get that 2nd place, so 6 times 5. Now, 3rd place, 2 of them have finished, so there's only 4 left. Then 4th place, 3 of them have already finished, so we have 3 left. And then 5th place, same thing, only 2 left. And finally, in last place, there's only going to be 1 runner left. So if we look at that, that is the same as 6 factorial, which is what we learned yesterday how to do. So 6 factorial, and we get 720 different ways that these runners can finish. Okay, now that's when we care about all of them. But as you guys know, unfortunately, the Olympics got postponed. But the Olympics, there's really only 3 positions we care about. Yes, fourth in the world is impressive, but you don't get a medal. Okay, so all we care about is that gold, silver, and bronze, the first 3. Okay, so if 6 runners are competing in the 100-meter dash, and we're assuming no ties, how many different ways can they win gold, silver, and bronze? So for this, we would only care about 6 times 5 times 4, and we can stop right there because I don't care how the last 3 finish. All I care is there's 6 people who get first. After one of them gets first, there's 5 left for second, and then there's 4 left for third. So 6 times 5 is 30. 30 times 4 is going to be 120. Now, there is another way we can do that. Okay, if you look right here, this formula is an easier way. This wasn't terrible with these numbers, but as numbers get bigger, I think this formula will be easier for us. So the number of permutations, remember order matters, of n things taken r at a time. So right here, p n choose r is how you read this. And the way we do this is n factorial over n minus r factorial. And r is how many we're choosing. So let's show that this works. So n is the total amount of competitors in our case. So we're going to start clear your thing and type in that 6. There were 6 competitors. Now over here to the left, you'll see NPR. If I click that, it pops up, and there were 6 people, and I want to know how all 6 of them can finish. Now you'll see, if we close our parenthesis, it fills in that formula for us. There were 6 total, and then n minus r, 6 minus 6. Now some of you might be thinking 6 minus 6, that's 0. 0 factorial. But 0 factorial is actually going to be equal to 1. Okay? Similar to how any exponent raised to 0 is 1, 0 factorial is 1. So let's go back. 6, choose 6 is how we write it. And we hit equals 720. That's the same answer we got here. Okay, so now for this next one. 6 runners, except if I would write it instead of 6 choose 6, it's now 6 choose 3. We only care about 3 places. Okay, so 6 choose 3. We go here, we clear it, and we do 6 choose 3, and we hit equals, and we get 120. So the same answer we had got before. I think that using this permutation button right here, now you can only use that button if there is no repetition. Okay, so the final one I'm going to talk about quick says the local Meijer store has 2 positions they're interviewing for. They're hiring 1 more cashier and 1 more cart collector. Okay, if 10 people are applying for the 2 positions, how many different ways can the manager decide to fill the position? Okay, so some of you might be saying those aren't different, but there's 2 different jobs. Okay, either you're a cart collector or a cashier. And once again, we have 10 total people. So 2 ways you can do this. You can either think there's 10 people that could get hired for the first job and 9 for the second, or we can use this button, the permutations. So P, number of permutations, when there's 10 people and we're choosing 2 of them. Okay, so P of 10 choose 2. So let's clear it. We're going to do 10 NPR, which stands for permutations. Choose 2, close that, hit equals, and there are 90 different ways that the boss can choose. Now, if you had chose to do it the other way, there were 10 people for the first slot. After one of them is hired, there's 9 left for the second slot. 10 times 9 is 90. All right. Hope you have a great day, great weekend. I'll get those grades caught up this weekend. Let me know if you have any questions. Thanks.